Why do we need logarithms? Most students can solve something like, what is 2 to the third equal to? Most students can comfortably tell you, well, that's 8. But what if you know the answer and need to find the exponents? For example, 2 to the x equals 8. That's where logarithms come in. So imagine that you have a bacterium, and every hour it doubles. So if you start with one bacterium and end up with 1,024 bacteria, how many hours have passed? This is asking for the result of an exponent. It's asking for the exponent itself. Questions like this appear in chemistry, physics, biology, finance, computer science, and many other fields. To answer them, mathematicians developed one of the most useful tools in algebra called logarithms. In this video, you'll learn how to read logarithmic expressions, convert between exponential and logarithmic forms, evaluate logarithms, work with reciprocals, and understand common logs and natural logs. A logarithm is essentially an exponent. And I've given you the basic formula here. All right, so y will be the power or the exponent that we're raising it to. B, this is called the base. This is the number that's going to receive the exponent. We often say the base is found in the basement because it's written below the line. X is the answer. So if I were to write something like the log 2, 8 like this. Okay, think of it like this. Okay, 2 is the base, and 8 is the answer. We raise it to some power of x. Okay, so you would mentally say, well, this is 2 equals 8 raised to some unknown power of x. So then we could say then that 2 to the x equals 8, so therefore x would be equal to 3 because we know that 2 to the third power is equal to 8. 2 times 2 times 2. Now, this base here, we'll say the base raised to the power of y is equal to x. We'll say that this base then must be greater than 0, and the base cannot equal 1. Now, we can't take the logarithm of a negative number because the base of an exponent function is always positive. No power of the base can make it a negative number. And we also cannot take the logarithm of 0. Logs of negative numbers are not real numbers. However, some calculators may show these answers sometime. So by using y equals the log of base b x, let's write the following. Write a log as an exponent. So log base 5, so that means that the 5 is written first. All right. The answer is going to be 25, and the exponent will be 2. Okay, let's try the next one. Okay, so I know that my base number is 6. I know that the answer is going to be the square root of 6. So I know that if I raise something to the 1/2 power, I'm taking the square root of it. All right, the next one. So the base number is 3. I know my answer is 9. So 3 squared is 9. Okay, on the next one, my base unit is 3. I know my answer is 1/9, -2. So by getting rid of the negative, that means I have to take the reciprocal. So that means that 3 squared goes to the bottom, so it'll be 1/9. All right, in the next column, let's write an exponent as a log. Okay, so that this 4 here is my base unit. So log base 4. Okay, raised to the power of 3. So that's the 3 is going to be my equals 3 over here. So I'm going to put my 64 on the inside of the parentheses. All right, again, log, it's going to be base 2. It's going to be an 8 inside the parentheses. And then 3 will be the power. So log base 5 of 25 equals 2. So 10 to the -4th equals 1/10,000. So we're going to say log. All right, my base is 10 here. Okay, 1/10,000. And my answer is -4. Okay, let's evaluate some logarithms. So log base 7 equals 49. So I know that 7 must be raised to what power to equal 49? Well, I know that 7 squared is 49. So x is going to equal 2. Next one. I know that 3 must be raised to some power to equal 27. So I know that that's 3 times 3 times 3. So that's 3 to the 3rd power equals 27. Therefore, the log of 3 of 27 is equal to 3. The log of 2/3 for 4/9. So what exponent of 2/3 could be raised to 4/9? Well, we know that 2 squared equals 4. And we know that 3 squared equals 9. So then I know then that 2/3 raised to the 2nd power is going to equal 4/9. So therefore, we could say then that the log of 2/3 for 4/9 is equal to 2. Okay, so 4 raised to some power is equal to 64. So we know that 4 raised to the 3rd power is 64. So we can say then that the log of 4 or 64 equals 3. Okay, let's evaluate a reciprocal. So y equals log 3 of 1/27. So let's rewrite this. So we can say that 3 raised to the y is equal to 1 over 27. Ask yourself, what power must 3 be raised to get 1 over 27? We know that 3 to the third power is equal to 27. So we'll take the reciprocal. So then we know that 3 to the negative third is equal to 1 over 3 to the third. So that's equal to 1 over 27. Therefore, we can say that the log base 3 for 1 over 27 will be equal to negative 3. Okay, the next one, log base 2 for 1 over 32. So 2 raised to some power is going to equal 1 over 32. Okay, I know that 2 times 2 times 2 times 2 times 2, or 2 to the 5th power, is equal to 32. So I could say then that 2 to the negative 5th power equals 1 over 32. Therefore, I can say then that the log base 2 for 1 over 32 is equal to negative 5. Common logarithms are log base 10. Sometimes you may see a logarithm written without a base. When you see this in mathematics classes, it almost always means the common logarithm or base 10 is in use. So in other words, instead of saying log base 10 of x, it will simply say the log of x. So it's implied that it's base 10 most often. So let's evaluate y equals the log of 1,000. That means 10 raised to the y power is equal to 1,000. So that gives me 10 to the third is equal to 1,000. Therefore, I can say then that the log for 1,000 is equal to 3. On the next example, so 10 to the y is equal to 1 million. So I know that 10 to the 6th power is equal to 1 million. So we could say that the log of 1 million is equal to 6. The log key is here on my calculator, okay? So this is log base 10, or the common log. So if I press that, and on the previous question we did like, what's the log of 1,000? So I'll say log, enter 1,000, close parentheses, and press enter, and it gives me a 3. Likewise, if I say the log of 1 million, okay, that should give me 6. But what if I wanted to go in the opposite direction? Okay, so go in the opposite direction, above the log key is 10 to the x. So if I asked you, what's the value of 10 raised to the 3.21? So I would go second log of 3.21. Okay, so it gives me the value of 1621.81 and change. So this is called the antilog, or the inverse of log. So it's a little different on different calculators, but most scientific calculators have this functionality. Here's an example of a common science question that may use logarithms. The amount of energy released from one earthquake is 8,500 times greater than the amount of energy released from another. The equation 10 to the x is equal to 8,500, represents this situation where x is the difference in magnitude on a Richter scale. So what is the difference in magnitude? Okay, so let's try that on a calculator. Okay, so I'm going to say, let's clear this. So the log of 8,500 so that gives me 3.9294. Okay, this shows that the earthquake, which was 8,500 times greater than the amount of energy released from another one, so the difference in magnitude will be 3.9294. So what's the value of y if it was 3.54? So we'll do the same thing again. Okay, so this time I'm going to go second log, and I'm going to enter 3.54. So it'd be 3467. That will be 3,467 times more than we're comparing. The most frequently used base for logarithms is base e, the value of which is approximately 2.71828. Base e logarithms are important in calculus and some scientific applications. They're called natural logarithms. The base e logarithm will be log e of x, and it has a separate notation. So when I'm showing it, I'm going to use ln of x. So we don't normally write the e here, but we'll instead just write ln for natural log. Then everything else is pretty much the same. If I have y is equal to the natural log of 500, okay, these always have to be done pretty much on the calculator. So to do this one, we'll go back to our calculator, and the ln key is what we'll be using. So if I do the ln of 500, which is natural log of 500, that gives me a value of 6.2146. Okay, instead of putting equal, we'll probably need to go approximately equal to 6.2146. Now, if I ever need to take the inverse of e, okay, that is on the calculator also. So if I need e raised to a power, I will go second ln, which is e raised to a power. So if I were to enter the 6.2146, okay, that gets us back to our 500 again. Before we finish, remember the most important idea from this lesson. A logarithm simply tells us what exponent is needed to produce a given result. If you can convert back and forth between exponential form and logarithmic form, you've already mastered the foundation of logarithms. From there, evaluating logarithms, working with reciprocals, and understanding common and natural logs becomes much easier. Take a few minutes to practice rewriting equations and checking them on your calculator, and convert them back and forth from exponential form to logarithmic form. If you found this video helpful, please be sure to check out other lessons on this channel. Please leave a comment, like, and subscribe. Thank you for watching.